Alright, so we're on our way into Chapter 2 and getting closer to calculus. Last class we talked about 2-1-1 and specifically piecewise functions, and we also gave a really simple definition of what continuity is. So I'm going to go over the flipbook notes right now. Alright, so this will be at the front of your flipbook in 2-1-1, and we're going to look at piecewise functions first. Alright, so the basic definition of a piecewise function, the one that CPM gives you, is a piecewise function is a function that uses different rules for different parts. We can think of it a lot like Chapter 1 in our logo project, how we took functions and then restricted them using the domain to look at just certain parts of the graph. So let's say we have f of x equals, and we're going to look at two different types of functions, but we're going to consider just one. So let's say 2x minus 5 for x is less than 3. And our other function will be negative x minus 3 squared. We'll look at a quadratic plus 3 for x is greater or equal to 3. So this is back to Chapter 1, it's just a different form. We're going to graph two functions on the same graph with the restricted domain. So if we set up our xy axis, the first one we'll look at, I'll color code it here, will be 2x minus 5. Think about your y-intercept. Go down 5, 1, 2, 3, 4, 5. Then our slope's up 2 over 1, up 2 over 1. And we're going to go all the way to 3. So our line should look something like this. Oops. Let's redo that. We know we're stopping the graph at x equals 3, so this is true for everything less than 3. If we were to draw this on a number line, it will help make sense of this. We go back to Algebra 1 and put in 3. You know it's going to be open circle, and we're going to shade everything to the left. Okay. Now, if I take my second graph, my quadratic, graph this, we got a bunch of transformations. We have a flip, and then our shift is 3 to the right and 3 up with our HK form. So let's go 3 to the right and 3 up. Let's plot the vertex, and we know it's opening down. Our A is just 1, so it's going to be down 1 over 1, and then 2 squared will be 4. So we go over 2, we'll go down to 4, which will be right here. And now we can go ahead and graph this quadratic that opens down. We're only looking at part of it again. We're looking at the part where x is greater than 3. So if I graph this on a number line, we have 3. Now we're going to make it a closed circle because it's greater or equal to 3, so it's included. If we look back now at our function, we'll notice that this function is not a function because it fails the vertical line test. You'll see there are two outputs at 3. So in order to get around this, we need to look carefully at our domain, especially on the blue equation. We see that x is less than 3, and we notice this open circle here. We need to translate that open circle on the graph also. So we'll go back to our graph, and at 3, oops, let's use blue to keep it consistent, and we'll make it an open circle. Now we only have one output at x equals 3, which is on my quadratic or my green graph, and that output is 3 also. After we graph it, we're going to do our domain and range. And the domain and range is for the whole entire function f. So if we look at domain as we're moving from left to right, you will see that there is no break in the graph. Even at 3, we have an x value at 3. Even though it looks like it jumps up, moving from left to right, it continues. There's values everywhere. So our domain will be negative infinity, comma positive infinity. Our range now, it's low to high. If we look at it, we're going low to high. So we start from negative infinity, and we move up, and you'll notice that the highest we can get here is positive 3. So our range is going to be negative infinity, comma 3, and because 3 is a point on the graph, see it as a point, we will have a closed bracket to say that 3 is included. So on your test or on your quiz, which you'll have coming up shortly, you will be able to use your graphing calculator to set the domain and graph it, but then you will have to know which function is open and which one's closed, and also how to write the domain and range. Let's move over to the next slide and talk quickly about continuity, which is the second component of 2-1-1. So I'm going to give you a really basic definition of continuity. We'll develop a more mathematical one later in the course, but for now this will do. Pretty much a continuous function is one that you can graph the function without lifting up your pencil. So keeping the pencil to the paper. So I'll give you a couple examples on this. Sketch an XY axis. Alright, so let's say our first one looks like this. This is a sinusoidal function, which we'll get to in second semester. You notice I drew that without lifting up my pencil. There was no break. Here's another type of continuous function. This actually looks like a piecewise function. You see two different graphs, and again, I don't lift up my pencil. If we go back to the piecewise function we did earlier, though, you'll notice it is a function, but there's a break. In order for me to go from my blue to my green graph, I literally have to take my pencil off the page and jump to that green graph. So this is a function, it just isn't continuous. So you can't have a function that's not continuous. Later in the course we'll develop a more formal definition, but for now, this basic definition of continuity is what I want you to know.